Hi, my name is Mel. I do a lot of tech videos and science videos and general videos about stuff I'm just interested in. I'm not going to record my voice in all these videos because I don't think anyone really needs to hear me going on, but with some of them I will have a voice. Okay, so this one is one of those, and this presentation will provide a detailed overview of servers, their types, software, how they function, and I'll examine the evolution, core principles, classification, software, deployment models, operations, maintenance, and emerging trends related to servers. We will begin by understanding what servers are and their importance in technology. Next, we'll explore how servers work and their core principles. Then we will classify server types and their applications, followed by software and management tools, deployment models, operational processes, maintenance, security, and future trends will also be discussed. The following section covers definition, history, and significance of servers in modern computing. Understanding the server's role helps grasp their impact on technology and digital infrastructure. Servers are specialized computers or software that provide services and resources to other computers, known as clients, over a network. They play a central role in managing data, applications, and communication. Server technology has evolved from simple mainframes to sophisticated cloud infrastructures. Key milestones include the development of client-server architecture, the rise of visualization and cloud computing. And in later videos, I will discuss all of these principles in more depth. Okay, I plan to sort of try and cover as much as I can in other videos as well. Okay. Servers underpin the internet, enterprise networks, and cloud services. They enable data storage, processing, and communication essential for business, government, and individuals worldwide. We explore how servers process requests, the client-server model, and the hardware requirements essential for efficient server operation. Servers receive and respond to client requests by processing data or running applications. Efficient request handling ensures reliable and fast service delivery. This model divides computing tasks between clients which request services and servers which provide them. It forms the foundation of networked computing systems. And I'll go into client server a lot more in another video. Servers require robust hardware, including very powerful CPUs, ample memory, fast storage, and reliable network connectivity to handle multiple simultaneous requests. And you wouldn't just go with one sort of internet service provider. You'd probably have two at least to have a backup if one goes down, especially for important businesses and government. Okay, you'd have to have redundancy, and we'll cover redundancy in another video as well. Servers come in various types tailored to specific functions, including web, database, file, mail, application, proxy, game, print, virtual, and media servers. Web servers host websites and deliver web context to users. Popular examples include Apache and Nginx. Okay, and they are things I know about and have used and set up in the past as well. Okay. Database servers store, retrieve, and manage data for applications. Examples include MySQL, which is popular because I think that's open source, PostgreSQL, and Microsoft SQL Server. Okay. File servers provide centralized storage and access to files within a network, facilitating collaboration and data management. Mail servers manage email sending, receiving, and storage, supporting communications in organizations and online. Application servers host applications and business logic, enabling complex processing and integration for enterprise networks. Proxy servers act as intermediaries between clients and other servers, providing security, content filtering, and caching for improved performance. And this is something that a lot of people would set up, okay? Game servers host multiplayer online games, managing player connections and game state synchronization. Print servers manage print requests and queue jobs, enabling multiple users to share printers efficiently. Okay. Virtual servers run multiple virtual machines on physical hardware, facilitating cloud computing and resource optimization. Media servers store and stream audio and video content to users, supporting services like video on demand and live broadcasting. The following section discusses popular server operating systems, management and monitoring tools, and secure software essential for server administration. Common OS server systems include Linux distribution like Ubuntu, Kali server, CentOS, Windows Server, Unix-based systems, each Apple servers, not really, but they can be used as such, each with unique features for server environments. Tools like Nagios, Zabbix, and Microsoft System Center help administrators monitor server health, performance, and availability. Firewalls, antivirus, intrusion detection systems, and access control mechanisms protect servers from threats and unauthorized access. And you definitely would have servers segmented from the network. The only thing I could think of having in a DMZ is web servers, and you would have them firewalled and protected, and you would also have firewalls and protected the other servers behind network segmentation with routers and switches and stuff like that. So you would have them entirely served, and you would have like a lot of protection, because you don't want them hacked or data breach or anything like that. Servers can be deployed on premises or in the cloud, come in physical forms such as dedicated, shared, blade and rack mounted servers. On-premises servers are physically located within an organization, while cloud servers are hosted remotely, offering scalability and flexibility. And a lot of people would probably have hybrid, like some stuff on the cloud and some stuff on the premises, okay? Just because that's probably the most realistic. Like cloud is expensive, on-premise is expensive. Hybrid, you can get the best of both worlds there. So that would probably what a lot of people would go with. Dedicated servers serve a single client exclusively, where shared servers host multiple clients, affecting performance and control. Blade servers are compact and modular, fitting into chassis, while rack-mounted servers are standard units installed in server racks for data center efficiency. Okay. This section explains how servers handle requests, balance loads, and maintain availability through redundancy and failover. Yep, important. Servers receive client requests, process them, and send responses over networks using various protocols ensuring data integrity and speed. Load balancers distribute incoming traffic across multiple servers to optimize resource use and prevent overload. Redundancy and failover systems ensure continuous operating by switching to backup servers in case of hardware or software failure. And redundancy and failover are really, really important, okay? So you should have multiple redundancies in your network, okay? So two, 3 servers, and like 2 ISP links, not just one router couple, like you should have redundancy. Depends on obviously your network setup, but you really should have redundancy, okay? Proper maintenance, backup strategies, and security protocols are critical to server reliability and protection against threats. Regular updates, hardware checks, and performance tuning help maintain server efficiency and prevent downtime. Effective backup strategies include regular data backups, offsite storage, and disaster recovery planning to safeguard data. And I want to really, really emphasize this. Please back up. You should have disaster recovery planning, do data backups, both on site storage and in the cloud too. Seriously, you really, really should do this. I can't emphasize this enough, okay? Implementing firewalls, encryption, access controls, and monitoring protects servers from malware, hacking, and other cyber threats. We conclude with new developments shaping server technology, including edge computing, energy efficiency, and AI-driven management. Edge computing brings processing closer to data sources to reduce latency, and this is something that's already available now, and most cloud providers do have edge computing. In fact, I think they all do. Microservers offer compact, efficient energy solutions for distributed computing, and these sorts of things are already being used all the time, okay? Innovations in hardware and cooling aim to reduce the environmental impact of data centers while maintaining performance. And like they're trying to develop technology that's not so energy using, like they're trying to develop hardware that uses a lot less electricity, because data centers use a lot of electricity. So they are trying to develop technology and other ways of trying to reduce that sort of impact. But it is important to know that with AI comes a lot of energy use and also environmental impact, okay? Artificial intelligence is increasingly used to automate server monitoring, fault detection, and resource optimization for smarter infrastructure management. And look, this is important too, but like anything else, AI does need humans there to help it, okay? It can't do it all by itself. It will do a lot. It will reduce a lot of the, tasks that are repetitive that people who manage servers or networks or data centers, but you need to monitor what the AI is doing, and you still will need to respond to a lot of stuff, okay? But it does help, and it will do continuous monitoring, and we will pick up things that maybe the humans can't, but the humans will pick up things that the AI can't. So this is important, that AI and automated server management cannot replace people completely, and that's important for organisations to know as well. So in conclusion, servers are the backbone of modern computing, and with diverse types, complex operations, and evolving technologies, mastering the principles and trends empowers organisations to build resilient, efficient, and scalable IT systems. Thank you for your time.